Hello everyone, this is Suresh. Welcome back to Google Cloud lab session. In this lab, we are going to perform basic feature engineering in using Keras. So without any delay, let me start the lab. And these are the following tasks we are going to choose. So launching the Vertex AI Workbench, cloning the repository to Jupyter Lab interface, and then perform basic feature engineering in Keras. Let me start up this. So you can pause the video and go through the objectives. So we are going to create the bunch of our notebook and input the data, engineering create category across the numerical feature columns. So here if you see in the Vertex AI, here we can see Collab Enterprise and Workbench. We are going to use the Workbench for this session. So Workbench is a good option for the projects and you can go through this because this also has a TensorFlow and PyTorch frameworks. So this setup is already done. That is why we are seeing the launch in the task one. uh, Navigation to and select where to say. That's what I did just a few seconds ago and enable all recommended API. And after this, navigate to the workbench. In the workbench, in the instances view, create a new instance. And here, change the name to lab workbench. Select the region as East 1 and East C as a zone. So I will leave the rest of the things as a default without any changes. Uh, Here advanced, what they are mentioning, the advanced is the like machine type, size, those things. So let's go through one by one. So this is going to be an instance and continue. So in the environment, the retail system environment, I'm leaving everything as a latest and default thing. And in the machine type, I'm selecting E2 series, which is having a 4 memory and 2 to 4 virtual CPUs. Here you can see E2 machine type as E2 standard 4 CPUs, 2 core and 16 GB. This is sufficient. And some other default numbers, default values. Here you can see data type is balanced persistent disk and which is having a 100 GB of data, 100 GB of data disk. And I'm leaving the network as default and IAM security as default. And once I see this health system, health check system health, click on create. So this is going to take about, with my experience, I was able to see about 5 minutes, 5 to 7 minutes. Let's see this. So you can see the creation is 18 p.m. Let's wait for a few more minutes. Till then, I'll pause the video. And if you need, you can go through the open the instance and you can verify the same things. Like the status is initializing, zone, machine type, GPU, there are no GPUs, default, and creation time, now backups. And you can see the hardware, whichever we selected earlier, this is the same hardware. Software and security, you can see the details and health. After a few minutes, the health status will get enabled and you can see everything. So once the status is active, then we will look into it. Now you can see the logs if needed. So I couldn't see the serial port. The instance is not in, start the instance. So it is still enabling. So let's wait for instance to start. Then only we'll be able to see the logs. Now you can see the Open Jupyter Lab is enabled. We will open this. It will open in a new tab. Let's look into the instance right now. So you can see the instance status is active, the zone, machine type, all the defaults, and hardware is 150, 100 GB is that the data disk, 150 as boot disk, and rest of it we already know. We already saw this. Software and security, everything is looking good. And health, you can see all the health has been, it's all healthy. And you can see the monitoring, and also you can see the logs has been enabled now. We'll see in few seconds. You can see all the details has been uploaded, and you can export the logs if needed. Okay, so going back to the Jupyter lab, we can see the lab is opened, and we can click on this Python 3 and rename something as test file, test Python. I just renamed it as a test Python, but you can rename it as you wanted. And now let's clone the repository. To clone the repository, just copy the code, which is copy the code and paste it in this, uh, and click on and select the shift and enter button, or else you can click on this run button in the cell. So you can run it in the cell. So once this is downloaded, we'll be able to see a training data analyst. So this will be a task 2. Let's wait for this process to complete. This process is completed. So let me navigate to this location. So training data analyst, inside training data analyst courses, machine learning, deep dive 2, feature, feature engineering, labs, 3, Keras basic feature engineering lab. So let me open this. Okay. Let me reopen it. I wanted to select the TensorFlow to -11. This is the step they are talking about. And click on select and click on edit and clear all outputs. So for the interest of the time, what I will do is like I will go through these solutions as well. You can click on the hint and there is a solutions provided. So I'm going to open the solutions as well for our interest of time. Keras basic. So the second file which I opened will have all the solutions. Let me select the TensorFlow for the second also, and I'll close the previous one and I will minimize as much as possible. From here on, we will perform the actions provided, tasks provided. At any point in time, you can pause the video and go through the steps provided. Once this is done, we'll get into the feature engineering in Keras. So I have changed the file. Now installing the scikit-learn. Let's wait for this to get into the idle. This cell is still busy. So let's restart the kernel, restarting the kernel restart. You can see the status, and the status is idle. Now importing the required packages for us, and also it is going to print the PF TensorFlow version. So let's wait for it. Now we have seen the TensorFlow version as 2.11. And now let's go into the Google machine learning post programming exercise using California uh, housing dataset. Let me open this. Okay. Uh, okay. So to unlock, I need to be as a Google Pro developer programmer. Okay. I don't know. I'm not the developer. So let's continue with this. So this is going to create a path as data as a folder and copying this data into this folder. Let's see where is this data is stored. Here, inside the feature engineering, you can see the data has been created. So now at this stage, we are going to copy this Google housing processing data sheet uh, inside the data folder. So downloaded, either you can verify this here, housing pre-processing, or what you can do is you can just list it. So we can see this housing pre-processing is there. Now read the data set. So we are reading the head in the data frame. We can use describe to summary statistics data frame. You can at any point in time you can pause this video and read it. So what the describe does. So we have the information, longitude, latitude, all the data. Now splitting the data set into machine learning. So training and test data set as 80-20, that is the test size, and training and validation 80-20, that is for the test size. Test train test split. We have two sets. Now let's see the length of these file sizes. So out of 2500, that is what we have seen here. So out of 2500, we have considered 1600 as train examples, 400 as validation examples, and 500 as test example. We need to output the split files. We specifically need to test the CAC later for testing. We should read the files up here. Now we are converting this train data to CSV and we are creating the housing train. You can see this here. Let me open. Just I will scroll. Now you can see once I run this train, automatically the CSV file will get created in the left side, as well as validation set, as well as test set. You can see this here. And we can see how many housing files are there. Head of data housing.csv head. So we get the top. This is from the test CSV. This section is from the train CSV. This is from the validation test set of CSV, and this is our original file. So here, let's start. Now wrapping. Now you can see this is a utility method which will copy the data frame and convert it into a TensorFlow data. So for that, I will use the solutions just for interest of our time. Labels. Let me copy these two lines and paste it over here. So now in this data frame, I am popping out the median house value. Let's see here it is. If you see in our previous data set, we have uh, median house value as a column. We are just moving out and putting it in a label. And our other label and tensor slices in the data set and shuffling the data. So this utility has been completed. Now let's see, the batch size is 32 to train set. We are sending the train, and for the data set, we are shuffling it. Now we have created an input pipeline. Let's call it to see the format of the data it returns. We have used small batch to keep the output readable. So here you can see for feature batch, label batch in train IDs dot take one. Every feature in the list has feature dot keys, households feature dot households. I mean feature batch. Okay, now let's run this. Now every feature longitude, latitude, housing median age, total rooms, total bedrooms, population, households, median. A batch for a tensor uh, batch is 185 some data, and the ocean proximity is of ocean proximity, and the batch targets label batch. Now we can see the data set returns a dictionary of columns from the data that map. Okay, numeric columns. At any point in time, you can pause the video and go through this. Now let's try for the all this is having the numerical values, right? Numerical columns. So of longitude, latitude, housing median age, total rooms, total bedroom, population, households, median info. Ocean proximity is a string that is nearby. So that is the reason we are creating a column scale before the fed into neural network. Here we use scalar definition. Okay. Let's scalar. So we are passing the feature into it, and it is taking the feature min, max, and returning the min, max. So let's get back, and also for the feature column. We should initiate the while. Okay, let's see the total number of feature columns. We have totally 8 feature columns. Now, model creation using the Keras sequential model. Now we have the dense features, feature columns, and float data type as float. Keras start sequential feature layer. Dense is this is 12, 8, and 1. That means first unit will have 12 units. Input dimension as 8, activation is relu. Second hidden layer will be 8, and final one output will be linear, which is a median house. So compiling with the optimizer as Adam, mean loss will be mean squared error and matrix, and model fit. It's going to be train data set, validation data set equal to train. So 32 epochs. Next we show the loss. Okay, we'll first execute this. So total 32 epochs is completed. So the mean square error, remember the mean square commonly used regression loss function. Okay. So let's collect the mean square error. It's 15. Now we will visualize the loss curve. Let's plot the MSEN. So you can see the training validation, the training model loss and model MSE. Now we will test the values. So let's see the test data set, test values. We have 500. Now predict. So linear media predicted mean value, mean house value is going to be, so first prediction, it's in inland, which is 360K. You can see the prediction here. And near ocean, it is going to be 198K. We can say this here. Engineer features to create categorical and numerical features. We already have a numerical columns identified. Now we will bucketize the categorical ocean proximity categorical column and housing median ranges bucket. Now run this numerical bucketize. Now categorical feature. So you can pause the video and go through this document if needed. Just opening this document for my future reference. Here we can see the bucketized features. Let's run and feature cross. In the feature cross, we will use vocabulary. It's very big code to explain, so you can pause the video and understand it. Now we have 11 features. Previously, you can see that we had only 8 features. Now we are going to create the feature 32 epochs. We are going to create a sequential model again. Now we can see the mean squared error is 15 and history curve prediction model. So let's create one last prediction model here. So it's 199K. So here this view the solutions we are almost getting 192K. This is because of the shuffling of data, because we have shuffled the data based on the data it's predicting. Now if you want to check the predicted for highland, the prediction will be different. Okay, fine. So this ends our tutorial. This ends our okay. So this concludes our session. So I will close everything else. I'm just checking whether if I missed anything. No, this is the end. So let me end the lab. And thank you for watching. Have a great day.